After understanding the difference between distance and displacement, we will now move to understand what do we mean by constant speed and constant velocity. When we say that the speed of a car is 40 kilometers per hour, what exactly we mean? We can write the speed something like this, which is 40 kilometers per hour. What it means is that in every hour, when the car is running, it will cover a distance of 40 kilometers, right? So if it is running for 2 hours, it will cover a distance of 80 kilometers. If it is running for 3 hours, it will cover a distance of 120 kilometers. And if it is running just for half an hour, it will cover a distance of 40 divided by 2, that's 20 kilometers. This gives us a clue that distance and speed is related. The distance traveled is nothing but speed multiplied by time, right? So for example, the speed is 40 kilometers and time is 2 hours, it will travel a distance of 80 kilometers. If the speed is 40 kilometers per hour and the time is half an hour, it will travel a distance of 20 kilometers. So this is a formula which now is there. If we represent distance by s and speed by v and time by t, we can say s is equal to v into t, right? This is valid when the speed is constant or not changing. Not changing, right? In other words, we can say that the speed is going to be distance divided by time, right? So all I've done is that I've taken the time to this side, and that's our speed. Now what happens, instead of distance, I put a displacement over here, right? Now this is displacement. And then we divide it by time. When we do that, we call it velocity. Okay? So now you know the displacement has two components. One is the magnitude and another is direction. Okay? So let's say the car was moving northward. In 1 hour, it goes 40 kilometers. So how do we define velocity then? We will say displacement is 40 kilometers northwards, fine, and it took an hour to go there. Then my velocity becomes 40 kilometers per hour northwards. Okay, so now we are providing two information, which is the magnitude as well as the direction. Hence, the velocity, which is like displacement by time, happens to be a vector quantity because we are providing two information, which is the magnitude, how much, and in which direction. Okay, so displacement by time is a velocity, it's a vector quantity. We can represent it by symbol v, but now we have to put an arrow on top of it to distinguish it from the speed, which is simply v, and this is our velocity, which is displacement by time. In symbolic term, v is going to be equal to s, which is the displacement, divided by time. Time is a scalar quantity. So we can rearrange it to write s is going to be equal to v into t. Now, if we look at this only in one dimension, when I say one dimension, which means we are only interested in motion in a straight line. Okay, so how does the motion in a straight line looks like? We are going to only move in a straight line, either in this direction or in this direction. We are not going to go up and down or anything like that. We are only going to move like that or like that or like that. Okay, so that's called motion in a straight line, and we are going to confine our definitions like that. Now, as we know it's a vector quantity, we can say like my displacement, for example, we want to measure displacement from here, and whenever we want to measure a displacement from somewhere, we call it as a origin. Okay, and now let's say this is 1, this is 2, this is 3, this is 4, this is 5 units. 1, 2, 3, 4, 5. Okay, so this is like 1 unit towards right, this is like 1 unit towards left, 2 units towards left, so on and so forth, right? For simplicity, what we can do, it looks quite similar to the number line. So we can simply say anything on the right hand side of this is positive and anything on the left hand side of it is negative. So now we can say this like -1, -2, -3, -4, -5, right? So if I move, if I'm at this location, I am say I am at location +2. If I'm at this location, I'll say I'm at location -3, like that, right? And we can just move from -5 to -2, -5 to +1, -5 to 0, and so on and so forth, right? Then we can track our displacement. So for example, if I move from 0 to 3, my displacement is going to be like this, and this time it is going to be +3, right? Or 3 towards the right. If I move from 0 to -3, then my displacement is going to be in the left hand side direction or negative direction. So I move from 0 to -3. So I'm going to say my displacement is -3, right? And by putting the number line, we can simply play around with the numbers and not using left, right, east, west kind of a thing. Okay, so that makes our life easier. Now, when we say the velocity, when it moves, if it is moving in this direction, of course, this is going to be this displacement divided by some time, and it is going to be a positive number. So in this direction, anything which is moving towards right has a positive velocity. Anything which will move towards left will have this divided by time, which means anything which will move leftwards will have negative velocity, right? So by just doing that, basically there's no need to say we are moving left, right, east, or west. We can simply say positive and negative direction, especially in the case of one-dimensional or straight line motion. So now let's take a question to clarify some of the concepts here, and that is going to really help. So I'm going to move to a question which is here. How to use S equal to Vt in the vector format? It is going to be S, which is our displacement, is going to be velocity into time. Okay. So all we have to first ensure that if we are calculating this, the unit of this and this actually matches, right? So we cannot say if the velocity is like in kilometer per hour, then we have to use time as an hour, and the distance which will come out is going to be in kilometer. If the velocity is in meter per second, then we have to use the time which is in seconds, and the distance or displacement which is going to come out of this equation is going to be in meters, right? So let's look at that example to clarify this. So yes, here is the question. Find the distance traveled in 3 minutes by a body moving with constant speed of 15 kilometers per hour, right? So our speed is not a vector, so I'm not going to put a arrow sign there, right? So speed is v, is going to be 15 kilometers per hour, right? And the time which is given here is 3 minutes. Now we cannot blindly say that the distance traveled is going to be v into t. If you say that like 15 kilometer into per hour into 3 minutes, it is not going to be 45 kilometers. That's going to be totally wrong. We have to ensure that when we are putting the time here, right, we have the proper unit. So we just do it in that way, right? So velocity is in 15 kilometer per hour. My time has to be also converted to kilometer hour actually, right? So 3 minutes is going to be 3 by 60 hours. Okay, now you can see here that this hour actually cuts, and basically now what we have is 15 divided by 4. So this is going to be 3 by 4 kilometers. And that is going to be a correct answer, not 45 kilometers. Okay. So we have to ensure that all the three things which you are going to put here are in exactly the same units, right? Now let's say part 2. Find also time taken by this body to travel 200 meter at the same speed, right? So I'm going to switch it to the next slide to do that. So we have to find the time taken to travel a distance of 200 meters. Okay. And the speed is, go back and check, speed is 15 kilometers per hour. Okay. So the speed now is 15 kilometers per hour. Is 15 kilometers per hour. As you can see here, this is given in meter, our speed is in kilometer. So we have to convert that into the same unit. We can do it either ways, but this one we will convert into kilometer. This is going to be 200 divided by 1000. So this will cut, and this is going to be 2 by 10 kilometers. And now we are going to use our formula. S is equal to Vt. We have to find this guy. So T is going to be S by V, right? What you have to find out for 200 meters. So S is 2 by 10 and V is going to be 15, right? And this is 15 kilometer per hour. So the hour is there. So now we have 5. That's going to be 1 divided by 15 into 5 to 75. 1 by 75 hours, right? We if you want to convert that into minutes, we can simply do that, right? By multiplying by 60. So that's up to you. But that's how we going to calculate. All we have to ensure that whenever we are using any formula, actually anywhere in the physics, all the things are in the same unit.